Hey, hello everybody, and thank you for attending. It's once again Friday afternoon, and time for week 8, for part 8 of our 13-part series called The Baker's Dozen: What is New in SQL Server 2012. And today we're going to finish up our discussion from last week. We're going to talk about the new analysis services tabular model in SQL Server 2012. A little bit of introduction on me. If this is your first time attending, my name is Kevin Goff. I'm a SQL Server MVP. I also train and run the curriculum for a training company called SetFocus. We're in Parsippany, New Jersey. I'll talk about them in just a second here. So going to go through some introductory slides and then get into today's demonstration. As I said, this is a 13-part series on the new features in SQL Server 2012. And this is as the old expression goes, a just the facts approach. I've always liked demos that went right into the specifics of the product and what types of things the product can create, and so all the demonstrations really follow that theme here. Now, my bio, if it's your first time, again, I'm a SQL Server MVP. I write for Code Magazine. I've been involved in a couple of books on everything from .NET to reporting to SQL Server Business Intelligence. I speak at community events, mainly in the Mid-Atlantic. I also said I'm a trainer for a company called SetFocus. They're located in Parsippany, New Jersey. Our website is www.setfocus.com. We also have about 100 hours of free training lifted from our curriculum on the areas that we train on, .NET, SQL Server, Business Intelligence, and SharePoint. You can go to that free training portal. It is freetraining.setfocus.com. If you want to send me an email, feel free to email me. My email address is kgoff@kevinsgoff.net, and my combination website and blog is www.kevinsgoff.net. I actually have a separate category on the right-hand side of my blog specifically devoted to these webcasts. So I'll keep this up on the screen here for just a second. It's really the only thing you need to write down here, and I'll also pop up this slide at the end of the presentation today. So again, we're going to look at the new analysis services tabular model. We actually started on that last week and going to finish up that discussion this week. So moving forward here, looking at the schedule, we're getting into the second half here. We're in week 8 of this 13-part series. Here are the previous sections we've covered. The slide deck and examples are up on my website. Again, it's just kevinsgoff.net if you want to go back and take a look at the slide deck or the examples from prior weeks. We are in week 8, and this is a two-part series on what's new in the tabular model within this 13-part series. Next week, we're going to start another two-parter on what's new in Power Pivot 2.0. So if you're not familiar with Power Pivot, or if you are seeing a little bit of it but are interested more in what can be done with it, feel free to tune in the next 2 weeks where we'll talk about Power Pivot. But for this week, we're going to continue our discussion about the new analysis services tabular model. Now, just as an overview from last week and kind of as a segue into this week, the tabular model is a new method in SQL Server 2012 for creating analytic databases using analysis services. Now, prior to SQL Server 2012, if you wanted to create analytic databases in the SQL Server platform, you used analysis services to create OLAP cubes. Well, OLAP has a lot of great functionality. I love OLAP. I love analysis services. I think you can create some pretty terrific things with it. But the observers of the product have noted, rightly so, that there is definitely a learning curve with learning analysis services and with learning OLAP. And so Microsoft created this new tabular model to create some of the same capabilities that you could with OLAP cubes, but maybe with a slightly simpler interface and a slightly easier learning curve. Now, as I also covered last week, if you want to use the tabular model, you have to create a separate instance from the normal default instance when you install SQL Server. So on my machine, as we'll see here in a minute, I have the normal database instance, but I also have a second instance for the tabular model. Now, we use SQL Server Data Tools, formerly BIDS, to create the new tabular model. So when you go into SQL Server Data Tools, you have the option to either create a normal OLAP SSAS project the way you normally could, or you can create a new tabular model. And this tabular model can pull data from multiple sources and we can do some of the same things that we could do with OLAP, with prior versions of analysis services. We can create data relationships between fact and dimension tables. We can build calculations. We can build KPIs. We can build hierarchies and perspectives. And we can even implement things like partitions and row-based security. So while not every last feature that's in OLAP is available in the tabular model, certainly a number of the major and popular features are, as we're going to see here. Now, a developer can deploy the tabular model one of two ways. Probably the most popular way is going to be an in-memory database on the server where this is deployed that uses formerly the Vertipack engine, now known as XVelocity. That's the column store index engine that we see with a column store index back in a relational database. And you can also deploy to what's called a DirectQuery mode. Now, if you're familiar with OLAP databases, this is similar to ROLAP, where the deployed model itself contains nothing but metadata. There's no actual fact and dimension data in there. So when people want data out of the model at runtime, the analysis services engine under the hood sends SQL queries back to the underlying source. So there might be some advantages to do that if we always need to get data out of a tabular model, but have it hit the underlying source in real time. Now, once deployed, end users can access this tabular model just the same way they could access a regular OLAP database through different tools. And I'm going to show a few today, like Excel services and reporting services. And later in this 13-part series, we're going to look at a new reporting services visualization tool called PowerView that allows people to access these tabular models from within SharePoint. Now, these tabular model databases can be used for large databases. So unlike other in-memory databases where there might be a physical limit, these tabular model databases can grow to be very large. Now, today we're going to look at a different demo than the one we looked at last week. Last week we looked at building part of AdventureWorks. This week we're going to create a model using a different database. Going to look at some of the same capabilities we saw last week, but with different data, but also going to look at some new capabilities. I actually have a book sales database for a publisher, and with this database, we're going to build some relationships, going to build some calculations, set up a few hierarchies, build a KPI, build a perspective, build some partitions. So I'm going to go through some of the things that you would normally create to build an analytic database. Also build things like security roles, where we can define that certain users can only access maybe certain accounts or certain book categories or whatever. So I'm going to get right into the demo here. So I will share my desktop. And give this a second. And we're going to hop right over and take a look at the end result. A lot of times in doing a demo, it's best to see what's the end goal going to be. You know, the little line about beginning with the end in mind. Well, we got it right here. Well, what I'm looking at right now is an Excel pivot table that is running against a tabular model. So just in the same way that you can create Excel spreadsheets against OLAP cubes, this is an Excel spreadsheet that has been built against a tabular model. This is the end result. This is what we're going to construct. Now, right now I'm looking at a pivot table where I can slice the data by year using the new Excel slicer visualization. So I'm looking at data right now for 2008. Now, I said this is a book publisher, and I actually have some book categories here. Books like ADO.NET books and ASP.NET books and C# books, and I've also got them by categories of customers, maybe college bookstores or internet customers or distribution centers or retail stores. Now, first of all, even though these are actual names like Amazon, these are made-up sales numbers. Please don't think that these numbers for sales or returns percentage represents actual data. This is completely manufactured, fictional, made-up data. These are not actual sales numbers. So right now I'm looking at sales by customer, and I've got things like revenue that's been aggregated by customer and by book category in the different dimensions here. And I've got the return dollars. Any retailer knows that the returns are a fact of life, but you want to manage them, you want to keep them down. Well, I've also got a calculation for returns percent. And because returns are such an important thing that we want to have a metric for, I've got a KPI. Well, sometimes with KPIs, higher is better. In this case, lower is better. The lower the return percent, the better things are. Well, for one customer here, the returns percent is about 11.5%. So the returns constitute about 11.5% of revenue. Well, maybe our goal, or our threshold, I should say, is 14.4%. And so obviously since we're below that, that's good. So we have a green traffic light here. Well, for Blackwell North America, we're slightly above the average, or slightly above the threshold. So that's a yellow. That's a warning. And then down here at the bottom, we've got a customer who's at 15%. That's well above the goal, so that's not good. So they're in red. Now, of particular importance here is the fact that the goal is actually data-driven by the customer category and by the year. If I take a look at college bookstores instead, notice how the threshold here is going to change. Instead of it being 14.4, it's actually 17. A lot of times when you take a look at examples of KPIs in books and on websites, you see the KPI hardwired, where you see the goal or the percent hardwired. Here it's coming from a fact table that's tied by the year and by the customer category. And then we've also got two different rankings here, ranking based upon the revenue and then also ranking based upon the returns. Now you can't sort on both, so as it turns out, the top customer based upon revenue is number 9 in terms of returns. And number 1 here, we're actually ranking from high to low. So Baytree being number 1 is not a good thing. It means they have the highest returns percent. So we're going to build this from some source data that's in AdventureWorks. Now, in the coming weeks, we're going to take a look at other things that we can do with the tabular model and that we can do with the DAX programming language. For instance, in the second tab here, I'm not going to build this one today. I'm going to save this for subsequent week. But we've actually got a pivot chart, and I'm certainly not going to teach people how to build pivot charts. That's easy. But what's not so easy is calculating things like sales for the same time period a year ago or the moving average. We might want to know for any one month, what was the sales 1 year ago at that time, and also what's the average sales been over the last 12 months, because we might want to see for any 1 month how we're trending compared with the 12-month moving average for any 1 month. So in subsequent weeks, we'll look at some DAX formulas, DAX being the programming language in the tabular model, to produce that. But we're going to focus on building the necessary models so that we can implement something like this. Well, back in SQL Server, back in my relational database, I have a little data mart here called Book Sales Dim. Now the main fact tables are going to be fact book sales, where we've got sales dollars. I'm just going to take a look at the columns here. We've got sales dollars and quantity of books sold by state, by customer, by date, by sales type, and since you could have a regular sale or a sale for an electronic book, a PDF, and then a book price PK. Now you might be saying, well, why wouldn't it be a book PK? Well, just to make this interesting, I've got a book price dimension where I've got each book and an instance of the price, because maybe the price could change over time. Actually, they've implemented this as a somewhat normalized, slowly changing dimension, where a price could change over time for a book, and we want to track the sales history associated with when the book was under a particular price. I've also got that related to a book dimension, where I've got, try that again, I've also got that related to a book dimension where we've got a master list of each book, the ISBN, the category of the book, and the name of the book. Now that book price could have been denormalized here into dim books. You could obviously flatten this dimension and denormalize it. Just to make things interesting here and to show that the model does support reference relationships, I've actually built that as a normalized, slowly changing dimension. And I've got other dimensions here like customer and date. If I take a look at the date dimension, I'll actually take a look at the data in here. This is a calendar that's been built ahead of time. Now, some people like to build calendars manually in a table. Other people like to use some of the built-in date capabilities that are in things like analysis services or the tabular model. I have to be somewhat honest. I'm partial to constructing a date dimension myself, because sometimes there might be other attributes that we might need to put in a date dimension for things like seasonality or other special events. And so I'm sort of partial to constructing the date dimension sort of independently of any one tool. That way we can use it across a variety of areas. So I've got one day in here for each of a couple of years, from 06 through 08, and I've got the corresponding month, the quarter, the year, and nice versions of the display for the actual date and the Saturday date. So I've got a weekend date in here that's calculated by taking the actual date and determining the Saturday date. So this is my source data. Now this could be in a somewhat hybrid or normalized or denormalized database. We're going to build a tabular model from this. So how do we go from this to something like this here in Excel? Well, I'm going to open up SQL Server Data Tools, and I'm going to build a new tabular model. So I'll click the File drop-down and select New and then Project, and I will build a tabular project. And I'm actually booting off of my E drive, so I'll call this project Book Sales Tabular. And this is going to be an analysis services tabular project. So I could create a full-blown multi-dimensional project the way you always could in bids. I'm going to create a new tabular project. And take OK. And wait for this to get started. Now in this project I've got an empty model. Now, first of all, I'm going to change the name from model to something a little bit more meaningful. So I'll go to Properties, and for the file name here I'll change this from model to book sales model. Well, I need to pull in the tables. So I'm going to go up in the main menu, up to the model drop-down, and I'm going to import from a data source. Now I could pull data just like we could last week from a variety of databases. I could pull it from SQL Server, I could pull it from an Azure database, I could pull it from Parallel Data Warehouse or other databases like Access or Oracle or Teradata. I could pull it from an ODBC source, so quite a bit of sources. I could even build it, I could even mash up data from spreadsheets or from text files. Well, it's really advantageous to try to pull from something that's been shaped in some way to begin with, as data modelers would say. While we can pull data from Excel files or from text files, and it certainly will work, it helps you. You're a better starting point if you point to a data that's been shaped in some way to begin with. So I'm going to pick that database, or I'm going to pick that database type. And for the friendly connection up here, I'll even give this a better name. I'll say SQL Server Sales Data Mart. And the server itself, I've got a couple of different instances out here. Should find my my local instance of SQL Server 2012. Seems to be taking its time there. Okay, there we go. SQL Server 2012. Going to use Windows Authentication, and I'm going to pick that database, which is Book Sales DIM, or Book Sales Data Mart. And I'll take Next. And I'm going to use the service account to connect. You could use Windows Authentication to set up a source for connecting back to that database. I'm just going to use my default service account. And I'm going to specify what tables I want to pull in. Now, I am not going to pull all of the tables. I'm only going to pull some of them. Now, I know that I want to pull things like fact return thresholds because that has the thresholds actually by year and by category. If I go back to SQL Server and I take a look at fact return thresholds, if I actually query that table, that actually has thresholds set up by year and by customer category. So I want to pull that in if I want to construct a KPI. Well, I also want to pull in fact sales and fact book returns. Now, I also have an evaluation table for instances where you can go up and evaluate books on Amazon or other websites. I'm more interested in sales, so I'm going to leave that one behind here. Now, I want to look at sales by geography. I've got a simple state dimension, by sales type, by date, by customer, by book, and by book price. Now, there are two that I'm going to leave behind for when we get into the DAX programming language a little bit more deeply. I've got an author dimension, and I've got a bridge table. The reason for that is this. We might want to look at sales by author. Now, keep in mind something. We sell a book. We don't sell the author. The author isn't on the sales record. Now, a book can be written by multiple authors, and an author can write multiple books. And when a book is written by multiple authors, there might be an author share. So we might ultimately want to take the sales and multiply it by the author share as a basis for determining royalty. Well, the tabular model doesn't support that one out of the box. We have to actually write some DAX code for that. Now, in wanting to keep this in under an hour or within an hour, I'm actually going to hold back on these two until we start talking about the DAX programming language a little bit more deeply. We are going to look at some DAX samples today, but I'm going to hold off on bringing them in. In the subsequent week, we're going to bring these in and see what DAX formula we need to implement in order to look at sales by author. The tabular model doesn't do that out of the box. We have to help it along with some DAX code. So for right now, these are the tables I'm going to select. So I'll take finish. And this is actually loading the data from those tables into the model. And this does it fairly quickly. And I have a number of things running on my machine right now. I'm actually running Windows Server along with running the necessary software to broadcast this presentation, and obviously running Visual Studio here. So quite a bit going on, even on a laptop with 8 gig of memory. And I've got about 300,000 rows in Factbook sales, so not a little bit more than AdventureWorks, but certainly not as big as a production database. And give this a second here. And that's completed. That has actually loaded the data. That has actually loaded the data into the environment here. I'll take close. Well, in the model drop-down, there are two general views. There is the data view and there's the diagram view. Well, if I go to the diagram view, I do see, or I will see here in a second, that some of the tables are already related because of existing primary key foreign key relationships. That wasn't the case last week when I pointed to views, where there were no relationships and I had to build the relationships manually. Here's some of the relationships have actually been constructed. Now, there is a little bit of surgery I need to do on a few tables here. For instance, the date dimension. I built some of the description columns, things like quarter description and short weekend and short actual date, but the truth is I can't sort on them because I'd be sorting them alphabetically, and we can't sort a month description alphabetically because January and June would, April and August would pop to the top of the list. And months like January would be further on down the line because it'd be sorted alphabetically. So what I'll do is I'll go back to the data view within the model and going to do a little bit of surgery on the date dimension, similar to what I did last week. So I'm going to go to the date dimension, and for the short actual date, I want to display that, but I want its sort to be based upon the weekend date. So there's an option in here to sort by, and I'll select the weekend date. And then the same thing with this. You know what? I actually picked the wrong column here. It would help if I picked the right column. So going a little bit too fast here. Okay, that short actual date, we actually want to sort it not by the weekend date, but by the actual date. Comparing apples to oranges here. So get that straight. And then the short weekend date, notice how it's actually updating here in the lower right corner. The short weekend date I'll go to the sort by, and I'll see that that's going to be sorted by the actual weekend date column. And then the quarter description, I will sort by the underlying quarter key so that I can display the quarters, but they're sorted based upon a composite key of the year and the quarter number. And then I'll do the same thing for the month. So I'll go to the month description, and I will set up the rule that that's going to be sorted by the month key. Now, in reality, I wouldn't want to show things like the date key and some of the other keys to the end user. I would only want to show the descriptions. I'm not going to go through them here, but what you can do is click on a column like the month key, and there is the ability to hide that from the client tools. Obviously, anybody can do that, so I'm not going to go through it here, but the columns that we want to hide to the end user, because we're simply using them behind the scenes for sorting, we can hide them from the client tools. All right, well, let me come back to the model view and specifically to the diagram. And I'm going to try to maximize the display here. And I'm going to zoom this in just a little bit. And I see that one of the fact tables isn't tied to anything. I intentionally made this where one fact table was tied to the dimensions, the other wasn't. Factbook returns, which I'll sort of slide to the middle here and try to put the dimensions on the outside, standard with a normal data warehouse diagram. I see the factbook returns isn't tied to anything. Well, I'll simply take the correct foreign keys and drag them around. So the state PK is related to the state PK over in dim states. I'll create that relationship. And that does take a second to create the relationship here, so just have to wait for that to catch up. And then the customer PK, if we want to take a look at returns by customer, is tied to the customer PK and dim customers. And wait for that to catch up. And we have a date PK that's tied to the date dimension. I'm not going to worry about trying to make the diagram look pretty here, just making it functional. So they'll tie that to the date dimension. And then finally, the book price PK. Again, we're not storing the instance of the book, but the instance of the book's price over time. So we have a separate book price PK that we will tie to dim book price. So I'll take the book price PK and tie that to dim book price. Now, dim book price is in turn related to dim books. So we can actually look at sales and returns both by book as well as by the instance of the price over time. So there's our type 2 changing dimension. Now, again, a traditional data modeler would say that should be a more normalized dimension, and I certainly don't disagree with that. It normally would be just simply trying to show that we can create a reference relationship here if for whatever reason we would need one. Now, we have the fact return thresholds out here, and the fact return thresholds are at a higher grain. They're by year and by customer category. Well, I'm going to try to drag the year over to the year and dim dates. I can't. That's because the year is not a candidate to be a primary key over in dim dates. Now, the full-blown version of analysis services, in talking about this, differences here, the full-blown version of analysis services with multidimensional OLAP actually does support that in its designer. You can actually take a fact table by, in this case, year, and drag it to a non-primary key column in a denormalized dimension, because under the hood, the full-blown version of analysis services creates the equivalent of a select distinct of that year, so it actually does permit it. Well, we're kind of stuck here. Well, back in the original database, there were two views that I intentionally held back temporarily. They were called VDIM customer category and VDIM year. and they were just simply distinct instances of the category and the year. Now, it would be nice if we could build an on-the-fly view in here. It would be nice if we could right-click and say, hey, create a view off of dim dates to get a distinct list of the years. Well, we really can't. But the only thing we can do is go back to the data source and pull in those two views. So, under the model, I will go to the existing connection, and I will open it, and I will pull in the two views that I previously didn't pull in. So we can add tables or views after the fact, so to speak. And when they come in here in just a moment, we'll take close. Well, now VDIM customer category and further out to the right, VDIM year come in. Now, data modelers refer to these as mini dimensions. They are conformed to the dimension from which they came, in this case from dim dates and from dim customers. So now I will take, stretch this out to the right here, I will take the year from fact return thresholds and drag that to the year in VDIM year. And then I will also, after that's created, I will also take the year from dim dates and drag that over into VDIM year. Now, if I had a much higher resolution, I'd spend time on making this diagram look better, but kind of hard running in the resolution I'm in. So this is functional, if certainly not beautiful, but it is functional. So get that out of the way here. And then I'm going to take customer category from fact return thresholds. So the grain here for the threshold is by category for the customer and year. And I'll drag that to the customer category. And then I'll have to take the customer category from dim customers and drag that into the customer category as well. That way I can look at thresholds and other fact tables by common dimensions. So I will take the customer category from dim customers and drag that over to the customer category here. And give that a second. Okay, so I am now able to look at thresholds by year and by customer category. All right, well, let's go back to Excel because it's important to remember what we're looking to build. Well, we want to roll up revenue, we want to roll up returns, and we want to calculate a returns percent. Now, I want to get over in Excel here before too long and actually take a look at some of my data, but we need to create these roll-ups in this calculation. So I'm going to go in the model drop-down back to the data view, and I'm going to go to Factbook Sales, and I'm going to tell it that I want to aggregate sales dollars. So I'll click on the sales dollars column, and I'll tell it that I want to sum that. So I'm now going to have an aggregation in this model on the sales dollars. So I can aggregate it by any related dimension. So if you can envision that diagram view from a second ago, any dimension that's related to fact sales, I can now slice the sales dollars. That's what analytic databases are all about. Well, now I'll go to my return table, and I will also aggregate the return dollars. I'll click on the return dollars, and I'll aggregate that. Well, what I also want to do, going back to Excel, is calculate a returns percent. Here's where we need a little bit of DAX code. Now, in the interest of time, I actually ahead of time created some DAX formulas that we're going to use here. And the first one is going to be the returns percent. Now, this is a basic DAX formula. I'm going to take from Factbook Returns the sum of the return dollars and divide it by, from Factbook Sales, the sum of the sales dollars. I'm going to round it to 4 decimals. Now, because the returns are stored in the database as a negative number, and I want the returns percent to show as a positive number, I'll just take the absolute value. Well, I'll copy that entire formula, and then back in my tabular model, in factbook returns, because I want this percent to be part of factbook returns, come down to the next cell, and up in the formula editor here, I'll actually paste in that formula. So we're going to have a formula called returns percent. Now that's calculating that right now across the entire database. Obviously, we're going to slice that by a couple of related dimensions. Well, let me test this in Excel right now. I know I'm not finished, but I could at least test it in Excel. Well, remember, in the tabular model, we saw this from last week, a developer can actually analyze this in Excel right away. I could click Analyze in Excel as running against the entire database. And what that does is it launches Excel. And creates a connection to that tabular model for me, so I don't need to create the connection. That's a pretty nice feature. Well, let me sum the return dollars, and that's 33 million. And again, these are made-up numbers. And then here's the revenue. The revenue is 281 million. Well, I'll look at the returns percent. That's 11.88%. I didn't format that in any way. Well, I'll break that out by dimension. I'll come down here to the customer dimension, take a look at customer category. Well, I see that that's broken out by customer category, and I can even break it out by year. So I'll come down to dim dates and break it out further by year. So now I've got the breakout of returns and returns percent for each year. Well, we have a threshold. We want to be below a certain amount by year and by customer category. That's what that separate fact table was. I'm going to come back to the model here and go back to fact return thresholds. Now we do have a column called return threshold, but I do need to have some type of an aggregation or some type of an average, because someone might be looking at 07 across all customer categories, or someone might be taking a look at retail stores across all years. Well, we need to have some kind of an average. Now I'm going to create a very basic DAX formula called returns goal that is going to average that return threshold by whatever customer and whatever date someone has picked. Now, someone might say, well, maybe you want to create a weighted average that takes into account sales. Well, you certainly could do that. I'm taking a very basic approach of just simply doing a straight average of the different return thresholds. If you wanted to factor sales into it, you certainly could, although that would obviously be a little bit more involved DAX formula. So I want to calculate the average of the return threshold over whatever related customer categories and dates I happen to have. So right-click and copy this, and I will put this as a formula in the fact return threshold area. And I'll look at this in Excel again. Now I will close Excel and just reanalyze it. I could obviously refresh in Excel and see that new measure. I could do that as well. Well, now in Excel, now I see that return threshold. Now it doesn't look like I gave it a better name, so it's calling it measure 1. I'll go back and fix that in a minute. So once again, I'll look at the sum of returns, the sum of sales, the returns percent, and I'll break it out by customer category and by year. So I'll go down to customers and put customer category down the left. And I'll even put the years across the top. So I'll go down to dim dates, and I will take the year and I'll drag it into the column quadrant. And I also meant to show the threshold. Well, in 2006, the thresholds here vary by the customer category. So for college bookstores, they were 15.5%. For distribution centers, they were 14.5%. And then in 07, we had a different set of numbers. So these thresholds are varying by customer category and by year. Well, now I can actually implement a KPI to compare one to the other. First of all, let me fix that measure up there. See, I was actually calling that returns goal. So instead of measure 1, a bit of a better name there, call that returns goal. And then I'm going to come back to the fact book returns area, and I'm going to construct a KPI off of that percentage. So I'll go to the returns percent, and I'll build a KPI. So I'll create a KPI, and it's going to compare the returns percent to the returns goal. Now, in this case, lower is better. So right now, if I want green to be something that's lower, so I'm actually going to flip these so that lower is better here. So there's actually a toggle. It's a little bit tough to tell, but there's an option here to make either a higher number better or to make a lower number better. Well, in this case, I'm going to slide these filters out. We want to be at the goal or below it. So in other words, if the returns percent is equal to the goal, in other words, if it's at 100% of it or lower, that's good. Anything maybe within 15% above the goal is okay or a warning. And then anything above that is bad. So I'll take OK. And I will reanalyze that in Excel. You can see that analyze in Excel capability is really nice. Keeps you from having to go in and set up the Excel connection manually. So once again, I'll take the sum of return dollars, the sum of sales dollars, the returns percent, and I'll break it out by customer. So once again, I'll come down to customer category, and I'll do the year as a slicer. I'll go to insert slicer, and I'll insert a slicer based upon the year. I'll come down to dim dates and select a particular year. And I'll do this just for 07. Obviously, the thresholds there change depending upon what year I'm in. And then I'll show the KPI. So I'll come up to the KPI area, and I will select the KPI. Well, I see that, and I meant to show the goal as well. I forgot to show the goal, so let me show the returns goal. So 13% is well below 16%, so that's good. And somebody here is at 14.5. That's above the 13.9, but not so high that it throws them into the red area, so that's a warning. Let's see if I can find a red area here. I'll tell you what, I'll go down and I'll expand, I'll go down to dim customers, and I'll break this out also by customer name. Well, it looks like everybody is in the warning area, so no reds in here, but that's just the way the data happens to shake out. So that's a basic KPI. Now, also in the final result, we were sorting this, or we were calculating a returns rank. So I might want to sort these by returns percent, and then show who was the highest, rank number 1, rank number 2, and so forth. And so we're going to put in one more DAX formula here. And then we're going to look at some partitions next. Well, once again, I've got a formula that I set up ahead of time. I'm going to implement a returns rank that's going to be based upon the returns percent. Now, ranking in DAX is a little bit involved. There is a function in DAX 2.0 called rankx. And what I want to do is I want to rank the returns percent. And in this case, I want to rank it across whatever customers I happen to slice data by. So we're going to rank using the returns percent across all customers. Now, keep in mind that I might have in a pivot table a grand total. And so I want to rank if there are rows for customers, but I don't want to rank the grand total. So I've got some if checks at the top First of all, to make sure the current customer name isn't blank, because I might be looking at the grand total. So a few considerations we have to implement when we do a rank. So I'm going to come back to the tabular model, and I'm going to put one more formula in here. It'll be a returns rank. So actually, just copy and paste the entire formula here. So I will go into Formula Editor and actually paste that in. And let me scroll up to the top, at least name this a little bit proper form. So it'll be returns rank, and enter. Now that doesn't calculate anything yet because we haven't provided any kind of a context. Well, I've constructed enough where we can try to actually create this chart, or at least a large portion of it. Now I'm going to actually do a deploy here. I'm just to be different. In Solution Explorer, I'm actually going to right-click and actually deploy this database. Now, if I go to Properties, this is actually deploying to my SQL 2012 tabular instance. So I will right-click and take the option to deploy. And this is actually physically building the OLAP database, or excuse me, the analytic database out to that instance of SQL Server. Okay, so that, another minute here. Okay, so that is finished, and I will go open up another instance of Excel just to show how you would do this from the beginning. And in the data drop-down in Excel, I will say from other sources and from analysis services, and I will put in from my server localhost, so I do need to know the name of the server, SQL 2012 tabular. And there is my book sales tabular project. That's what I called it, book sales tabular. And I'm going to create a pivot table. Actually, because the end result here, I have the pivot table down further, I'm going to create it a little bit down further here, so I actually start it there. And I'm going to bring in the revenue, the returns, and the returns percent. So I'll start off with the sum of the return dollars, and then we had the revenue. Okay, I'll flip these. That's no big deal. So it's the sum of the returns, some of the sales dollars, the returns percent, and then we showed the returns goal, and then the returns KPI. So I'll pull the status from there. And we also are going to show the returns rank. Now, right now, there's no rank because I don't have any customers. And remember, that DAX formula only would rank if it discovered a customer name. Well, I'll go down to dim customers, and I will put the customer names down the left in the row labels. Now, notice how the ranking is all fouled up here. That's because I need to actually sort this by returns percent. And so I will actually click the row label drop down, and I will go to more sort options, and I will sort this in ascending order by the returns percent. And I actually will also filter and only show those customers who have sales. So I'll click the row label drop down to the value filter, and I'm only going to filter on those where the sales dollars is greater than 0. I only want to see those who have sales. And I'll actually change the sort option and sort this descending order by returns percent. So if I want to see who's best, well, Baker and Taylor is, I'm sorry, who's worse. Baker and Taylor is actually worse. They have a 13% returns percent, whereas somebody like Quantum Books down here, they have 11%. Now, the KPI for all here is good, but I'm going to break it out now by year. Well, I can insert a slicer. So I can go up and insert a slicer and go up and select year from the date dimension. And we put the slicer on the left here. And probably should have stretched this out further. And I'll look at it just for 2007. Well, now I get a different story here, where some are a little bit above the threshold. Well, I also want to be able to look at just a customer category. So I'll go up to the customer category within the customer dimension, and I'm going to implement that as a slicer. So I'll go to the insert area, and I will insert a slicer based upon customer category. And put that along the left here as well. And I'll look at just internet. Well, obviously I get a shorter list here. Well, if I also maybe want to break it down by book, I can go to the filter, and I see that one of my available dimensions is the book dimension from up at the top here. Well, I'll go up to the slicer one more time. And I'll break this out by book category. And I'll put that over here on the right. So maybe I want to look at this just for SQL Server books. Well, now it's a little bit of a different story. The returns percent for SQL Server books seems to be higher. So we're now getting the ability to provide the analytic slice and dice capabilities in Excel with really about 30 minutes worth of work here in the tabular model. Pretty impressive stuff. All right, now I'm not trying to make this look as nice as this, but hopefully you get the idea. All right, some other things we can do in here. I promised that we would look at partitions. So I'm going to actually close Excel here. I'm going to come back to the tabular model. Well, let's say that fact book sales is a very, very large fact table, and maybe we want to break it up into partitions. Well, what I can do is up in the menu, I can go to partitions. And right now, fact book sales is just one big fact table. It's 355,636 rows. Let's actually go write down that number. It's 355,636. Anytime you're building partitions, very important to do some basic testing. And I'm sorry, that was what, 355. I think I need new reading glasses. 355,636. Well, I'm going to build a partition. Well, first of all, I'm going to change this, and I'll call this archive partition. And I will change it from pointing to the table to building a query. And what I'm going to do here is I'm going to join this to the table dim dates. And that'll be on from being equal to from dim dates, the date PK, and from dim dates, the year being less or equal to 2007. So anything 07 and before will be in the archived partition. We validate that, and that's valid. And I don't feel like typing that in again, certainly, so I'm going to copy that, and I'll click OK. And, oops, didn't mean to go out of there so quickly. Let me go back into the partition area because I need to create a second partition. So I will click New, and this will be active sales, and actually brings the query forward for me. I'll change this to greater than 2007. And I'll validate that, and that's valid. So I've got two different partitions here. One is for data before or during 07. one is after 07. Now, certainly you need to make sure that the total number of rows in the two partitions after we're finished is equal, or obviously we've got a problem. This will not protect you if you either drop data or double count data, so the onus is obviously on the developer to make sure that they make sure that every row is in one and only one partition. Well, I'll take OK here. And I will actually, there's an option in here to process those partitions. So I'll process both of these guys here. And it's reading through both fact tables from the source data. And we get 146,050 rows in one and 209,586 in another. Now those numbers do add up to the 355,636. They actually do add up. So now, obviously you would do more tests. You would want to first sum the sales dollars from the original fact table that covered everything, and then sum the sales dollars afterwards after building these partitions to make sure you get the same numbers. Obviously some testing that you want to do. Well, if I close this, and if I were to redeploy this, now the end user would not see anything differently, but this is now actually going to be working on two different partitions. So if someone ran a lot of queries against the active data, obviously that active partition is going to be smaller and therefore is going to perform a little bit better. Now, other things that we can do in here. We might have a user who only looks at SQL Server books and only for Internet customers. So we can build roles in here. So I'll go to the role area. And in the role area, I will create a new role. And I'll call this Internet SQL Server books. That's the only books that that person can see. And that'll be a read, just a read permission. Then I'll come down to dim books. And I will say in here, and I could actually use IntelliSense, and I'll go down to dim books and book category. And I'll say that that is going to be equal to SQL Server. Now, if you've built roles in analysis services against OLAP databases, you'll know that you could actually make selections from a list. Unfortunately, I'm not aware of any way that you can actually pull the metadata. To the best of my knowledge, you've got to type this in. I'd love to be proven wrong on that, but to the best of my knowledge, you've got to type in the actual string value. Well, then I'll come down to dim customers, and I'll say that that is going to be from dim customers, the customer category being equal to Internet customers. Well, I'll click OK. And to test out that role, I can actually launch Excel with the Analyze in Excel option and utilize that role. So give this a second. And I will now analyze this in Excel, but I'll do it based upon that role. This is a great feature. It allows us to test without signing on as the person or the member who's associated with that role. So I'll test using that role. And that'll launch another instance of Excel here. And we'll be wrapping up in just a couple of minutes. Just one or two more things to show here today. So let me come over to Excel, and I will pull in the sum of sales dollars. Now I know that something is up here because I don't get the 280 million I had before. I've got 23 million. So I know immediately something is up. I will come down to dim books, and I'll pull in the book category and pull in the books underneath. And I see that the only books I get are the SQL Server books. And if I go to the customer category within dim customer, and I put that across the top, well, the only one I have is Internet. And if I break that out, if I put the customer name inside of there, well, I just simply get the customer categories like Amazon and Baytree and so forth. And again, this is just made up sales data. These are not actual numbers. But again, the numbers here reflect just that role for SQL Server books and for Internet books. So implementing this is very, very easy. All right, couple of things remaining here. I am using the default storage methodology that's known as XVelocity, otherwise known as Vertipack. And so that is actually building an in-memory column store database that's being hosted by the Analysis Services Tabular Model engine. So there is a living, breathing physical database out there. Now there is an option within the model and within this project. If I right-click and go to the properties, there's the capability to turn on what's called DirectQuery mode, which means that this model is nothing more than a proxy. There's no actual data in it. The Analysis Services engine will turn around and run SQL queries back to the relational source. We might want to do that. If we need real-time access to data. Unfortunately, if I were to actually change this to the DirectQuery mode right now, I'm actually going to get an error. It's going to go out and read the database, and I'm going to get an error, and here's why. If I go to the details, well, I'm using row-level security. There are certain options in the tabular capabilities that are not supported with DirectQuery, and that row-level security is actually one of them. I'd have to turn that off in order to implement DirectQuery. And as it turns out, there are other capabilities as well in the tabular model that aren't supported with DirectQuery. For instance, if I use certain DAX formulas that do things like read data for the same time period a year ago, well, that's more than what DirectQuery can handle. So there are some instances where, depending upon what you put in a tabular model, you might not necessarily be able to turn around and make it a direct query mode. And row-level security is one of them. There are certain DAX formulas that aren't supported as well. So when you downgrade to the direct query, and I do use the term in that, in my personal opinion, you are downgrading because you are losing a little bit of functionality. You have to make sure that you don't have certain functions turned on in the tabular model. Okay, and I'm reading a question here that someone asked. When filling up the filters for the role, should the value used in the filter need to be present in the data? Developer data may not have all the country data when migrating, so will the values be valid? That's a good question. I believe the answer is yes. If I go back to the role, and if I this is going to sound crazy, but if I make up a state that I know doesn't exist, if I say equals dim states and state name equals no state. Obviously there's no state called no state, but we don't know that at the time. I don't believe we're going to get any kind of an error. I'll redeploy that. Now, if I try to test that out in Excel, obviously I'm not going to have any data because there's no state called no state. But I don't believe that the value has to be present. That's a great question. Let me redeploy this, and I'll test it in Excel. Now, when I test it for that user, I don't expect to get any data. Obviously, you'd have to wait for that data to actually show up. So I'll just wait to deploy this. Give this a second here, or two. And just one other topic, and then we'll wrap up for the day. Okay, so that's finished. Let me take close. And no errors so far. If I go analyze in Excel for that role, I've never tried this before, so I'm on I'm on new territory here, but I'm going to guess that if I try to look at sales data, I'm going to get nothing, which is what you would probably expect here. But no errors so far. So I'm in Excel. Let me bring in the sales dollars. I get nothing. So I would expect, obviously, that once those sales dollars show up for that state, that we would get data. So that's a good question, but it seems to work the way one would expect. So, okay. Now, last topic here. I intentionally left back the author data. I'm going to save that for another day because that gets into some DAX formulas that are a little bit beyond what I want to cover here today. There's a bridge table of books to authors. If I go actually take a look at the data here, well, in most instances, there's one author on a book, so the author share is 100%. But if I come down here further, here's a book 137, that was written by 3 authors. Well, let's say that book sold $100,000. Well, author 139 wrote 20% of it. So their share would not be 100,000, it would be 20% of that 100,000. So the base on which we would calculate royalty would be the 100,000 multiplied by 0.2 or however we would do the math. Well, in the full-blown version of analysis services, with a many-to-many bridge table like this is fairly easy to implement. You obviously have to know how to model the data, but the analysis services engine in the full-blown version of SSAS with the multidimensional OLAP capabilities can handle this. And we actually don't have to write much in the way of code. In the analysis services tabular model, it's a little bit of a different story. The many-to-many bridge relationship won't be recognized in the same way. We'd have to actually write some DAX code to take the sales dollars, which are in Factbook sales, which are by the book price PK. We have to actually write some DAX code to tap into the relationship into dim book price, which in turn is related to dim books, which in turn is related to the author table through that bridge table. I'm going to save that for when we cover DAX, because that's obviously a very important formula. Some people have bridge table relationships where they have some kind of a ratio or share or other rate that they want to relate to a fact table through a bridge relationship. And so when we get into DAX in subsequent weeks, we're actually going to look at that formula. So that is the tabular model. But the only thing I didn't cover here today, I'd actually covered it last week, but I'll show this one last thing, and then we'll wrap up here. I didn't show how to build a hierarchy. Actually, building a hierarchy is very, very easy. If I go to the if I go back to the model view and go back and look at the diagram, well, I can build a hierarchy for any one of these dimensions. For instance, in the state dimension, I've got a very basic geography hierarchy for zone, region, and state. Well, what I can do here is just simply right-click on dim states. I can construct a hierarchy. And wait for this to update here. And the hierarchy I'll call GeoTree. And all I need to do, a little bit of mouse trickery here, but I basically need to drag the zone and the region, the state, one by one, where it has the section to drag the columns to the hierarchy. So we just simply do it visually. So the first level is the zone. And wait for that to update, running a little slow here. And then the next level is the region. And then the next level is going to be the state. And so in an end user tool like Excel, or reporting services or any other tool that's capable of reading this data, this hierarchy can be used. So we've now got zone, region, and state. And then finally, if I go analyze this in Excel as soon as that finishes, well, in Excel, I'll take a look at just the sales dollars, and I'll come down to the state dimension, and there's my geo tree, and I can just put that into the row area, and I've got the breakout of east and west, and the individual regions, and then the states. So same hierarchy capabilities are available. The full-blown version of analysis services are available here. So again, not every last feature that you'll see in OLAP is in here, but certainly a number of the major features are. And so the learning curve here, a little bit easier than it is with the full-blown version of analysis services. Now, as you're going to see, you sometimes need to roll some DAX code in order to implement things that the built-in model capability doesn't provide. So DAX winds up being an absolutely critical tool for developers who are using the tabular model. Okay, going to come back to the slide deck here, and we will wrap up here today. Now, I didn't cover looking at this in different reporting tools. In a subsequent week, I'll show how we can access this in reporting services. If you've ever built a reporting services report against an OLAP cube, it's the same process. You can point to the database in the same way and get the same capabilities. All right, next 2 weeks, we're going to turn our attention to the capabilities that are in Power Pivot. Now, what you're going to find in Power Pivot is that there's a certain amount of commonality between the capabilities we saw here in the tabular model and what we can do in Power Pivot. Now, because this is a two-part series, I'm actually going to show how we can take both tabular model data and Power Pivot data and push it up into SharePoint and see what we can do with the data once it's up in the SharePoint site collection. So that's what we've got on tap for the next couple of weeks. And then we're going to have a session on what's new with DAX, and then we're going to look at the reporting services integration with SharePoint that's in SQL 2012. Then the final week, we're going to look at the new Power View data visualization tool that's available for SharePoint. So that's a wrap for the day. Again, any questions, feel free to email me. Put my email address back up here. For some reason, there we go. So my email address is kgoff@kevinsgoff.net, and my website, www.kevinsgoff.net. So thank you all for coming. Hopefully see you all here next week, same time, same station, or close to the same station. And have a good weekend, and have a good week, and hopefully see you back here next week. So long, everybody.